Hi everybody, Ms. Martineau here from AP Physics doing the Cartesian diver buoyancy demonstration. So this YouTube video is going to be linked to the document. So if you weren't here to witness this demonstration live in class, you can take a look at the demonstration here and then answer the questions appropriately on the document. So once again, what we have here is the two big ideas of this demonstration is that water is an incompressible fluid, but air is a compressible fluid. And the other part about this is Pascal's principle. According to Pascal's principle, if we have a sealed container filled with incompressible fluid, then any pressure that is exerted is the right word there, any pressure that is exerted on the container will be transferred equally throughout the container everywhere. This is the idea of hydraulics. Right, so if you put pressure on one end of the container, you get the same pressure at the other end of the container. And please see the document about applications of Pascal's principle in terms of hydraulic lift. However, this is what we have here. This is our demonstration. And it's a demonstration that hints at the idea of buoyancy. So let's get into it. I have a bottle here. It's filled completely with water. Water is an incompressible fluid. Inside of the bottle is a soy sauce packet floating inside the bottle. Soy sauce packet contains two kinds of fluids. One, an incompressible fluid, the soy sauce, which is basically water, and air. There's a bubble of air at the top of the soy sauce packet. Air is a compressible fluid. If you don't believe me, look it up. Air is classified as a fluid. It does flow just like water does. So what we're going to do here is we are going to compress the bottle. Now, rewind. I just said that water isn't compressible. That's true, but I am going to squeeze the bottle. So while I might not compress the water, I will not make the volume of the water change in any way. I am going to put the water under pressure. So here we go. So I'm going to squeeze down here, and we notice that the soy sauce packet sinks so long as I am compressing it. So long as I am putting the bottle under pressure. Once the pressure is released, though it is not immediate, the soy sauce packet floats back up to the top. So another thing that we want to talk about here is the idea of buoyant force. So buoyant force is a force. It pushes. You can think of buoyant force as a normal force from a fluid. So just like normal force pushes up from the desk, buoyant force pushes up, but the thing that's pushing is the water around the object. And this buoyant force is only going to be directed upward. So you want to think about this two forces acting on the packet. One is weight and one is buoyant force. I'm going to demonstrate one more time. I'm going to put the bottle under pressure again. Now I want you to think about what pressure is the soy sauce packet under. Keep in mind that the pressure inside of a contained vessel is the same everywhere if it's filled with an incompressible fluid. So ask yourself, if I squeeze this bottle and I increase the pressure, am I squeezing the soy sauce packet? If I squeeze the soy sauce packet, does the volume of the soy sauce increase? Keep in mind, soy sauce is an incompressible fluid. If I squeeze the bottle, does the volume of the air inside the packet increase or decrease? Air is a compressible fluid. So that's the two things I want you to think about. And then think about the forces acting on the soy sauce packet when the soy sauce packet is being squeezed and not squeezed. Okay, which is a bigger force when the soy sauce packet is when the bottle is squeezed, which is a bigger force acting on the soy sauce packet. What's the bigger force when I am not putting the bottle under pressure? And those are the two things I want you to think about. We're trying to make connections between buoyant force and pressure and volume, actually. Please read the questions in the document. That'll guide you along with this demonstration. Please answer the questions in the document in full sentences like a science student. And thanks a lot for watching this video. We'll see you next time. Thanks. Bye.